Well, hello, I'm Bob Plankers. I'm a technical marketing architect from VMware. I work in the Cloud Platform Business Unit. That is the unit that is responsible for vSphere, VMware Cloud on AWS, things like that, the Azure components as well. We take that, we're the foundations of the software-defined data center as VMware sees it, and we take that very seriously. My job in particular, as a technical marketing architect, I'm half evangelist, I'm half developer relations, and those developers are our own developers most of the time, and I'm half escalation point for customer and field questions and things like that. And so it's a really interesting position to be in between all of these different organizations. I want to talk a little bit about CPU vulnerabilities. These are the most vexing things around right now. I mean, other vulnerabilities might be more or less serious in a sort of tactical nature, but these are systemic. These side channel attacks are systemic problems in our hardware. And what the trust models flow up. You know, we want to be able to trust our hardware. What happens, you know, we talk about zero trust. The NSBU folks later will probably talk about zero trust. And, you know, this is sort of the assumption that your CPU is keeping all of your stuff separate is sort of the original zero trust. And we find out things about that, you know. VMware, I really like these icons. VMware, we tend to be a little bit soulless and humorless and refer to them by all the CVE numbers and things like that. But I'm joking. It's, you know, MDS, for example, represents 5 different vulnerabilities. And so, you know, referring to them specifically, and how do you mitigate for those depends. You don't just mitigate for MDS, you mitigate for other things inside. You know, same for Spectre and Meltdown and all these sort of things. RAM bleed is the latest one, you know, a true side channel attack. DDR3 especially, but DDR4 is still susceptible. There's just more noise there that makes it harder to collect data, you know. And, you know, coordinating this sort of stuff. You know, Spectre came out in, January 2018. And, you know, turned security researchers onto this whole new class of problem. And then, you know, it's been game on. You know, let's get the schematics for this stuff and start attacking it. And, well, you see where we're at right now. You know, this is why we can't have nice things, you know. And after Spectre and Meltdown came out, and there was a lot of chaos around the release. Because it was just like, here it is, you know, like. And it became really clear that the industry had to coordinate a little bit because Intel was caught off guard. They weren't ready with the fixes, so they pushed something out the door that caused problems with hardware. You know, it turns out hardware has software in it too, the firmware and things like that. And cloud providers may or may not actually ever update that, which, you know, please patch. Please patch. Please patch your firmware. Please patch your operating systems. Please patch your applications. And please patch your phones, things, everything, please, you know. And so the coordinated effort, MDS was a coordinated effort over the course of a year, 5 different research groups around the world, over a year working on the fixes for it, microcode updates, getting it tested to make sure that what happened, the problems that we saw with Spectre and Meltdown, as far as chaos, are minimized, you know, and so that customers have a direct way forward. IT has got a direct way forward. Whether that's true or not remains to be seen. But let's talk about L1TF. L1TF is real, you know. It's an attack using hyperthreading. Symmetric multi-threading, SMT, the generic term for it. Hyperthreading is an Intel term, an Intel trademark. The idea that there's a sibling running on the same CPU. These CPUs have got so much stuff in them now that somebody came up with the idea that, hey, why don't, instead of, well, one thread is executing, why don't we preload data into what we can on the other side so that a context switch, a process switch, is faster. And we gained about 30% performance there, and that's an important number to remember because I'm going to take it back from you later, but yeah, seemed like a good idea, especially since computers, CPUs are really fast, and the rest of the computer is really, really slow. I like this chart. I stole it from Brendan Gregg. I stole it from the internet, who stole it from Brendan Gregg. He's a Netflix guy. He wrote Systems Performance book, which is pretty good, and now I don't feel so bad about stealing it now that I've given him credit for it. Actually, this has been around in some form since the early days of the internet, early days of computing, really. What's novel about it is the scaled, and I keep backing up so you folks can see, the scale on the other side here, that if one CPU cycle is a second, going out to a rotational disk is the equivalent of 1 to 12 months worth of wait for a CPU. And that really does a good job selling solid state disk and NVMe and things like that. But it gives you a good sense of that, CPUs are just sitting there waiting for things. And so they can there's certain things that they can do to improve that. And one is just data locality. Try to keep data. If you need something from main memory, if you need something from disk, try to be able to predict what you're going to need and get it in one of the level 1, 2, or 3 caches that are much faster comparatively than going out to main memory. And this is actually where a lot of the performance problems come in with things like Spectre and Meltdown. The fix for those is to clear those caches. And so now you're having to go back out to main memory all the time. You're having to go back out to, to other layers of the stack. And that sucks. Not to mince words here, but, so the other thing too, and my apologies to the Wu-Tang Clan, but the idea that if caches are fast, can we make more space for them in the power envelopes for a CPU? Can we make more space for them on the dies to maximize those caches? And this is all playing up. This seems like a great idea, that's, we'll maximize the CPU, the caches. We'll also teach the CPUs how to do a few tricks. One of them is out of order execution. The idea that I've got all this work in front of me. Do I have to do it all in sequence, or can I do some of it in parallel? Can I break it up? Maybe I need some memory, or maybe this is going to need a memory access over here, maybe over there. I got to talk to somebody on the network over here, whatever, friends, yeah. And but I can work on this and this and this and this, and get that stuff done ahead of time, Out of order execution, superscalar execution, run things in parallel. And then, and that's great until you run into something where you need to make a decision. You need data in order to make a decision. You need to do a computation or whatever. It's called a branch, and so a CPU is sitting there waiting. It's got nothing but time, right? There's nothing, it wastes millions of clock cycles all the time, every second, waiting for data and things like that. So it can do other things. Hey, while I'm waiting, why don't I just do some branch prediction here? Maybe it's Boolean and true or false. I can predict the rest of the outcomes there, and that when I get the actual data, I can just jump to the end. I don't have to do all that work. I'll just store the answers and then I'll just, jump to the end. Fork in the road for a computer program, as it were, That's speculative execution. And, that was a great technique until January 2018. At which point, the sibling thread, it was discovered that, L1TF, 2018 was Meltdown and Spectre. L1TF especially, a sibling thread could be anything. You've got VM1, maybe it's Active Directory Domain Controller, something like that. VM2 on the other thread could be ESX. Turns out ESX uses the CPUs as well, and what does it do? It does encryption, it does, all kinds of stuff. And the sibling can ask the CPU for data belonging to the other sibling. I can ask the CPU for, my sister's journal, and the CPU is like, Bob, you cannot read your sister's journal. Point of fact, I don't have a sister, but so making this all weird, but fully involving my family in this whole presentation. But we haven't gotten to my dad or brother yet, but
Getting there.
both cool folks. But so the CPU is like, illegal maneuver, you can't have access to that. But if the data's in the L1 cache, yeah, you can. And game over. You can just ask the L1 cache, hey, it's like, a police property room going down there, like, hey, can I have that box? Yeah, sure, here you go, The CPU does the right thing, but the other pieces of it don't. And so that's a real problem, and we need to start managing what's co-scheduled there. This is not theoretical either. There's a YouTube video of a commercial pen testing tool that is sitting there sucking credentials out of an Active Directory domain controller, and what better thing? Why do I need to break into the rest of somebody's infrastructure to move laterally? I'll just log in, and it's a little scary. The MDS. So moving on to MDS. So we thought we had L1TF sort of figured out. And I'll get to our remediations for that in a second. MDS came along and said, yeah, you don't really. I'm going to use a new feature I haven't ever used in this. Oh, it's not available. Look at that. I don't have the software's not on this thing. There's a highlight thing that I can do. The middle of this, I guess I do have a mouse cursor there. The middle of this thing is buffers. I mentioned that security researchers are, curious animals, and somebody discovers something and they all glom on looking for, other novel ways to break CPUs and things. Somebody took a look at, hey, what are all those buffers in the middle? Line fill buffers, load buffers, all that sort of stuff. What sort of security is on those? Yeah, no. So the downside of this is I've lost my mouse cursor here. Let's see. So those buffers there don't have a lot of security on them. They leak a lot. And those buffers, that's unfortunate because it affects things like the Intel Software Guard extensions, SGX. SGX is a secure enclave, supposed to be a secure enclave for secrets and things like that. It's in the hardware. It's only the applications can get to it. There's a bunch of gotchas with SGX anyhow. It's only available on single socket CPUs right now. And I say this because, every once in a while somebody's like, oh, SGX is our next messiah. And well, there's some operational issues there. vMotion is a real important thing for maintenance and patching. Patch, please patch. Please patch. Patch. Change your passwords. When you break vMotion, you don't really break vMotion. When you pin a VM to a particular host, that becomes an operational problem. That stuff will get worked through. But SGX for right now, this stuff leaks all of the SGX stuff. Your secure, your super duper, double super secrets that are stored there, yeah, they're not so secret. Your sister is reading your journal. So.
As long as your sister's not reading it, because she doesn't.
That'd be weird, So, I'd have lots of questions about that. There's probably some, religious framework out there that is totally cool with that whole, reincarnation and somebody coming back as my sister or whatever. But we need beer to talk about that. So not right now.
Yeah, a little early.
So what do we do about moving forward? What do we do about these sort of things? Well, fix the hardware would be ideal, but there's, this stuff is present in everything that's out there. It's, the 15-year-old boxes we've got in our test environments that are heating our data centers have these problems. Even some of the modern stuff. The researchers are even just going back and forth about whether the recent releases of CPUs have them, or whether, different families have these problems. AMD is differently affected than Intel, for example. We often talk about Intel, but AMD has got some of these problems as well. They're just not as large, so they don't get as much attention right now. But, power. ARM has got, some of the ARM manufacturers have got these problems, and so it's, how do you deal with it? It's a fundamental problem. Well, what VMware did, what we did at the vSphere level, was create a new scheduler. So our default scheduler assumes that everything on a host can talk to each other. And in this new world that we live in, basically all these secrets are, anything running on a host, it should be assumed that it can see everybody else's stuff. Very communal operation there. It's also the fastest. It's not imposing any sort of limits, security boundaries, that sort of thing. L1TF came along, and we created the side channel aware scheduler version 1. Actually, at the time, it was just the side channel version, side channel aware scheduler, because we didn't know about these other ones coming along. And available in all of our vSphere versions. And it effectively ends hyper-threading at the software level. Can you shut off hyper-threading in the BIOS? Yeah, but modifying hardware is a lot harder for our customers, and being able to set an advanced setting is a lot easier. So we effectively don't use hyper-threading. I'd like that 30% performance boost that you got from hyper-threading. Please give it back. Pass it to the end here, and we'll collect it. The highest security, lowest performance. Well, it turns out the security boundary doesn't always have to be the process. VMs are a really nice security boundary as well. And a lot of things, it can be assumed from time to time. Edward's over there smiling, again, it can be assumed from time to time that things inside of a VM have the same security parameters, the same security levels, and perhaps they're sharing stuff anyhow, so what difference is it if things leak or whatever? And that's a choice. That's a business choice. It's a business choice around risk. Looking at what you're doing. But this is a side channel aware scheduler version 2. We created this to allow some co-scheduling. So a VM, a multi-threaded, multi-CPU VM can be co-scheduled on sibling threads. Now, there's a performance hit there. It's about 10%, but that's better than 30%. And, it gets us some performance back. It's a good stopgap, especially if you've got performance overhead problems. There, your cluster's pretty full. I mentioned business risk. This is a business decision, a risk decision. This is not a decision the techs can make by themselves. Everyone in the stack needs to get involved. And one of the big forks in the road, one of the big branches, as it were, is, are you running untrusted code? No, I'm not running untrusted code. Nothing on my laptop is untrusted, except that PowerShell thing I downloaded from the PowerShell gallery, or maybe my web browser. How many times have we seen malicious code being delivered as an ad? Container registries are the scariest thing I've seen in a long time. I just looked at one the other day that one of their premier partners, their premier vendors, had their flagship piece of software in a container. Last updated 2 years ago. 2 years ago. There have been 8 critical security vulnerabilities. I looked it up. 8 critical security vulnerability alerts, and each one of those had multiple things in it for that particular product. Should you download that container? Absolutely, go for it. What is there to lose, right? No, please don't. I'm being sarcastic. Watch where you get this stuff. We discovered a couple of weeks back that there's containers that don't have any root passwords set. That. It's very easy to develop on that. It's very easy to break into it. But NPM, there was, 2-3 years ago, there was a paper about how malicious, how somebody, to see if it was, how easy it was to insert malicious code into an open source project. They picked an NPM module or whatever, and a pull request, and it was accepted, and now there's a security vulnerability in there, and they wrote it all up, and oh, by the way, you need to patch. WSUS, people cache the Windows updates. Well, one, why? Given bandwidth and things like that nowadays, and they, Yum, APT, DNF on Red Hat Enterprise Linux 8 and Fedora and stuff like that. Those pesky GPG warnings, it won't let me patch because I'm using a Puppet repository or something like that. That's I didn't import the key, and that's pesky. It won't let me install something, so I just shut the GPG check off. Why not? I don't know. I just want to go home and drink beer, right? So that's why it's really important to make it easy to do the right thing, because people will skip steps. Maybe not people in this room, but people in general. And it might not even be intentional. You know, they take a call from their dead mother or something like that, and then, you know, and what the heck? And then I forget about what I'm doing, and, you know, I just go on with my life, that sort of thing. Virtual appliances too. I don't even have to get into that. So the moral of the story is here, if you're really interested in security, it's SCA version 1 or bust at this point. We lost hyper-threading, at least on Intel, and you know, SCA version 2 is better than nothing. Better than the default scheduler. So, I left this slide in here. You know, remediating for a CPU vulnerability is kind of a complicated thing. It's got business decisions, it's got risk decisions in it, you know, and it's not just straightforward patch. You know, you have to go talk to somebody, especially if your clusters are full, especially if your clusters are within 30% of their maximum CPU capacity, you know. Update hardware firmware. Well, you know, there's a lot of organizations that have forgotten about hardware firmware, you know, just fire and forget. You know, cloud providers are awful about that too, you know. Interesting thing, vSphere, if you patch, please patch, if you patch vSphere, you will get the latest CPU microcode with it. We actually ship that, and we will update the microcode when ESXi boots. And it's not the full package from Intel or AMD. It's just what we need to get the instructions that we're looking for. MDS, the MD clear instruction, things like that. And so we always recommend doing the hardware firmware. Hardware firmware, you also get, you know, all the other ecosystem on your box. You get, you know, you nodding your head, you know, network drivers. You get, you know all of the stuff, you know. And iDRACs on Dells, they have their little computers. They need to be patched too. Patch vCenter, please patch vCenter first. Always patch vCenter first. Then you set the scheduler flags, patch ESXi, and the hardest thing is power cycling all the guests, because that's a customer facing thing. That's an architectural problem now. You know, did I design my application to withstand this sort of thing? Because the virtual machine monitor, the process that runs the VM itself, only picks up new CPU information when it's instantiated. So a long-running VM, and you know, something that's been patching, a Windows box that runs Windows Update every month, that's great. Thank you very much. Good work. Unfortunately, that's not a power cycle operation. That VM stays up, and so it won't get new CPU instruction information until it's powered down. And so that's hard. Last thoughts on this. You know, these are hardware issues. These issues were not created by VMware. We're trying to help our customers get through them. My coworker Mike sometimes calls it somebody put sugar in our gas tank, and we're just trying to get to the finish line, you know, as a group here, you know. And so, but we're willing to help. If people have questions, please reach out. What Edward and I were saying earlier, please send us feedback. I'm always willing to take feedback, positive, negative. Please, constructive's nice, you know. Cascade Lake, Cascade Lake is the latest. Intel's got, it's the scalable Xeon processor 2 or something like that. You can look up the marketing name for it. They fix a lot of the stuff in hardware in different ways. If you're running vSphere 4.1, you know, this might be a good, yeah, not you of course, but maybe asking for a friend. You know, you know, that would be a good goal to have. You know, Epic 2, the AMD CPUs. You know, so AMD doesn't have all the same vulnerabilities, but they've got other issues. Their interconnects and things like that between the CPUs aren't as friendly to things like vSAN and things like that, cache coherency. So definitely check out what you're looking to do there. RAM bleed's a hard one. We really can't fix that. We've thought about, you know, is there something we can do in software to help that? Can we add noise or whatever? But you know, to try to make the attack less effective. And noise eats up RAM CPU and memory bandwidth.
That the Rowhammer thing?
Yeah, it's the new version of Rowhammer. Okay. So, yeah, the being able to read things, yeah, straight out of RAM and that's kind of scary. Oh, I have an Intel, the 2nd generation Xeon scalable processor. I have it in my notes. I'm proud of myself. I'm not even looking at the notes anymore. Performance testing. All of the performance data prior to MDS is junk. VMware is updated. We've got a performance benchmark called the VMMark. We've updated ours for, I believe, L1TF now, and they're working on MDS as well. But you really have to watch that. If somebody says, hey, I can do X, I can process X widgets in an hour or whatever, is that with the remediations on or off? It really makes a difference. Last thing I'll mention here is the VMware Cloud on AWS. The way it's the public cloud, the way VMware envisions it there, a piece of hardware is allocated to a particular customer. It's not shared among the whole fleet of public cloud customers, and so that changes the dynamic around the security boundaries. And so that's an important distinction there for customers that are using that. You know, it's basically on premises, except it's not on premises. So. With that, I invite questions. I thank you very much. Questions, comments, pirate jokes, ferret comments.
So that means if you are on the Amazon cloud and you get an ESXi, that is yours, and
Yep.
no other customer will be on it.
No other customer will be on that piece of hardware.
So that kind of mitigates some of the attacks.
That helps a lot.
Because otherwise, I mean, if you share it, that would be a big problem.
Yep. Rowhammer, RAM bleed in a public cloud context.
Okay, thanks.
Which
Yeah,
version of VMMark do we need that has the new version in it?
The latest.
Late.
I don't know what version it is. I want to say like 3.1 or something like that, but I'm totally grasping at it. The VMMark website would be a great place to but, I know they updated for, bless you, I know they updated for L1TF, and they'll do that for MDS as well. But, you know, that's the hardest thing about, you know, system design and things like that is how do you size for something now? You know what a workload looked like before, but especially with, and that was one of the big problems with Spectre and Meltdown is to fix those things, they cleared the cache, and that was really, they cleared caches. That was really destructive for IO-intensive operations. IO-intensive operations saw multiple 100%, you know, hundreds of percent performance decrease. So. Other thoughts, questions, comments? No?
When I started using vSphere, I was on Mac, so I was very excited when 5.0 came out.
Yeah.
That was the first time I could actually use my Mac. But is there, I mean, I haven't used it for a while, so apologise if it's a bit of a silly question, but is it more looking to work with everything versus like, because obviously we're a lot more mobile. Is there the look of like not only security by default, privacy by default, brilliant, they're my favorite things, but also work in such a variety of environments. Like as a student, which is why I used 5.0. The challenge I had is it didn't fit my student life at all.
Sure.
And what I see in industry is people, because they can't test it in like a very out of hours, very mobile testing environment, because day job, they're doing their day job.
Sure, yeah.
I find there's a lot of, it's a lot of challenges with getting to the point where they're able to then, you know, incorporate it, as well as once they do have it, being that, you know, sometimes they work from home, sometimes they're on the train. I mean, in London, half the time the trains are like delayed, so you're sat there fixing major issues on your tablet. Like, is that kind of a direction that we're going in?
So yeah, the general overarching answer is yes. You know, embracing the more mobile, more connected sort of thing. There's a fling out there right now about management on tablets and phones and things like that, and that's just going to get better. I mean, we do flings because they're fast and easy to do. You know, get something out there, get some feedback. Fusion and Workstation, the new versions they're usually testing grounds for new features and things like that. ESXi, and those teams, the Fusion and Workstation teams, are really on top of stuff. Like the 1903 Windows 10 release broke Workstation, for example, and it was fixed. Also, VM Escape was fixed at the same time. Please patch patch, change your password. And the, do you see a trend here? Yes. But the,
Sticker idea for you.
but then ESX2, you can run ESX nested as well. So, and in fact, that's how we do all of our own testing. That's how all of our labs are, all that sort of stuff. Nested, it's officially not supported.
Yeah.
Because, should you run production stuff that way? Probably not. That's an area that we don't want customers to get into because it's just a rabbit hole of infinite proportions. But But nested ESX is one of the biggest gifts as far as testing things, trying stuff out. In fact, we're bleeding into my next segment here, actually, about, I mentioned this, the nested ESX, one of the best ways to test and develop confidence in a process or procedure or a configuration or whatever is to do it. Plus, you can snapshot it, and then when you break it, oh my goodness, just revert the snapshot. Done, magic. I do that all the time in my own lab,
Yeah, that was basically school.
Yeah, well, and that's the thing, and it takes all the fear out of trying stuff,
Yeah, that's true.
So.
My other quick comment, question-ish, was about when you were talking about the alignment with, I think this might have been a bit more in your first talk, but with kind of compliance and security and all of that considerations. Your comment about the kind of, what's it called, duplication in operations and security.
Yeah.
The reason that's really interesting to me is because, again, as a consultant, a lot of the times is getting the product sold, and also, not sold to the techs, but sold to the people that sign the checks. And the one thing I've noticed is, even though there is that layer, like duplication, that actually makes it much more effective to sell it. So you can be like, actually, this box that you check, it's better because it doesn't cost you more, but it solves multiple problems. And so that kind of leads into my actual question: do you guys have like a look at regulations and requirements for different regulations around the world, and do you have like kind of like the, I don't know if you know the NCSC, the National Cybersecurity Centre in the UK, and they have like publications on, for example, the board and their requirements for security, and they break it down for why you would choose this and why you would do that and what your roles are. Do you have something like that for the different products?
Yeah, so I mentioned the different business units within VMware. We've got a business unit called ISBU, the Integrated Systems Business Unit, and within them is a group that focuses on compliance. Okay. And it's not just US. I talk all the time about US. If we want to talk about compliance, there's the world of regulations or whatever, and I don't want you all to fall asleep, so I just stick to the stuff that I've got in my history and that. But certain different countries have got different regulations and all that sort of stuff, and those folks really know all of that stuff. In fact, they've got a database. You tell them what products you have and what versions you're running, and you say you want to be whatever, like GDPR, thank you.
Is that a thing?
I know.
Okay.
Maybe.
Only for us, not for you.
It depends on who you ask.
No, it's for me too.
But they will tell you, they can tell you what all of the controls are.
Oh, so they've mapped it all out?
They've mapped it all out. In
That's
fact, it's
sexy.
patent pending even. So we've got this whole team that can do this, and one of our big challenges moving forward as a company is how do we take this information and make it actionable, make it usable to folks like yourself, the VVD add-ons or whatever, that's one facet of it. Building it into monitoring tools and configuration stuff is, like what Edward was saying, that's another thing, and doing this not just for US stuff, but for everyone, so.
My last really, really quick comment on that is you've got those checklists and that essentially, but do you script them at all, even just for auditing perhaps?
Yeah, so the hardening guide, the vSphere hardening guide,
Yeah.
it's a giant, like literally giant Excel spreadsheet, and
Yeah.
there's a column in there of all the power CLI commands and all that stuff to do. Yeah, so it's got all of that stuff. In fact,
great.
Mike won't add something to it unless it's got a power CLI command. So
That's
we're actually waiting for people to, and he's pretty straightforward about it with our developers. We need to be able to automate that. The other stuff is in varying states. It's always a work in progress.
Are those available or just to the people that have the products?
All of the stuff that I've been mentioning is freely available to everyone
Lovely.
at this
Okay,
point.
last question. I'm done. You can go.
I'm just
Yeah, let's do one more question, and then I think I need to move on to the next session. Roger's
If I
giving me.
change to the scheduler thing from the normal one to the more secure ones,
Sure.
is that an operation that I can do while everything is running, or do I need to shut down?
It's a flag that you set, but you're going to have to evacuate the host and reboot it. It's red at boot time, and
That's good to run DRS.
yeah. So DRS is nice. Maintenance mode is cool, and hey, while you're at it, patch.